So for today's section, we're going to look at this piece of paper. We're going to talk about the discriminant. Okay, so the discriminant, it's based off quadratic formula. Okay, so we're going to talk about the discriminant today. And you can just take notes right on the back of this piece of paper. See this piece of paper here? In the packet, go to the back and write the word discriminant. Now, the reason the discriminant is so important is because it will tell us a lot of information. You're going, what is a discriminant? Well, let's look at quadratic formula. Okay, here we go. We're going to sing it. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. That's quadratic formula. Okay, we know that. We've been using it. That's what we can use to solve our quadratic equations, for any of them, or if they can't be factored or written as square roots. So this right here is the discriminant. The discriminant is b squared minus 4ac. And as you've been doing quadratic formula, you've probably noticed this. Depending on what the discriminant is, it determines what your solutions will be. Okay? So, for instance, if I get a 0 under here, notice that it totally wipes that out. Well, think about it. If I get a 0 under there, it totally wipes it out. So I'm just going to have negative b over 2a, which, yes, is the x-coordinate of the vertex. But what it really tells you is you're only going to get one solution. So if I get 0 here. So my options, or for what my solutions can be, if the discriminant is 0, then I have one solution, and it's one real number solution. So remember, real numbers are everything we've been talking about. A real number is rational or irrational, so it can be a repeating decimal or non-repeating decimal. So I can have a non-perfect square, okay? So I'm going to get one solution, and it's going to actually be a rational number. Okay, that's getting a little more detail than you need, but it's going to be a fraction, a number over a number. So that's going to actually be a rational number. So I'm giving you more than you need, but it's okay. If the discriminant is 1, it's greater than 1, greater than 1. So if what's underneath here is greater than 0, then you're going to have 2 real solutions. Now, they might be perfect squares or non-perfect squares. We don't know that. But if it's greater than 0, then we're going to have a real solution. You're going to have 2, because you're going to go whatever this is plus that, whatever this is minus that. But you're going to have 2 real solutions. Now, if it's less than 0, okay, another way to say this is that it is positive. So if the discriminant is a positive number, it's greater than 0, you're going to have 2 solutions. If it is less than 0, the other way to say that is that it is negative. And we've kind of talked about this already. If I have a negative underneath a radical, right now I cannot solve it. So what we say for right now is that we're going to have no, and this is the important part, real solutions. And we haven't learned enough to solve those right now, but I am going to tell you right now, just so that you realize what's going to happen there is that you are going to have imaginary solutions. They are not imaginary. It's a poor name. They are solutions that do exist. But if I have a negative, I cannot simplify it right now with the current knowledge that we have in Algebra 1. And they're what's called an imaginary number. And yes, they do exist. It is the square root of -1. That is all there is. So that's because I get the square root of -1. We don't know how to do that. We're not going to deal with it right now. Just take my word for it. So do not write no solutions, because that is wrong. It is no real solutions. Now on these, I don't care if you put the word real on there or not. But on this one, you can't just say no solution. You have to say no real solution. Okay, so let's look at that worksheet. So turn the paper over. This is what we need to know. Okay, so let's write up at the top what the discriminant is. That's b squared minus, square root of b squared minus 2ac. 4ac. Sorry, I have to sing the whole song in order to get it. b squared minus negative b plus or minus the square root of b squared minus 4ac. This is our discriminant. What's underneath the radical? That's the discriminant. We don't need to know anything else. So let's look at what the discriminant is here. Here's a, b, and c. So we have negative 2 squared minus 4 times a times c. That gives me 4 minus, calculator. So 4 times 6 times negative 3 is negative 72. So this is 4 minus a negative, so that's a positive 76. Okay? So if I have a positive number, how many solutions do I have? 2. It's not 0. 0 gives me 1 solution. It's not negative, so I do have 2 real solutions. Then it asks for what the solution would be. So then what we have to do is we just have to plug it into quadratic formula. Okay? So just take out a piece of scratch paper. And we already have the discriminant solved. So that means I'm just going to plug in the rest of quadratic formula. Remember quadratic formula? Negative b plus or minus the square root b squared minus 4ac all over 2a. So we already have this part. So for instance, on this first one, number 1, we have negative b, so negative 2, plus or minus the square root of, we've already done it, it's 76 all over 2a. So I'm going to get 2 plus or minus the square root of 76 over, 2a, that's a 6, over 12. That's a discriminant. I can do it as a decimal. Are there any perfect squares in 76? Let's see, 76 divided by 2 gives me 38, so 4 probably goes in. Let's try it. 76 divided by 4 gives me 19. So this actually breaks down into 2 plus or minus square root 4 and square root 19 all over 12. So 2 plus or minus 2 square root 19 all over 12. Okay. They want the decimal answer. This is the accurate answer. And I'm going to show you, because we have time today, you can factor this out. I can factor a 2 out of the top and bottom. So I'm going to take a 2 out of both of these, so I get 1 plus or minus the square root of 19 all over 12. That can be reduced. See how I can cancel out a 2? And I get 1 plus or minus the square root of 19 over 6. I want you to see that so that you get used to it. But the answer, so I say the answer is 1 plus or minus square root 19 all over 6, which is true in simplest form. However, I can also give it as a decimal, so now I'm just going to plug this in, so that would be 1 plus square root 19 over 6, 1 minus square root 19 over 6. So take out your calculator. Square root of 19 plus 1. That 1 plus square root 19 equals. Now see how I get this? It's because it's just saying, yeah, whatever. Okay, toggle it. Gives me a decimal. I'm going to divide that by 6. So I get 0.89. Here, 1 minus square root 19. Okay, see how we get that? And what I mean by toggle it, this right down here, send it, it's right now in square root, send it to decimal. So I get negative 3.35, divide that by 6, and I get negative 0.56. So if I want my decimal approximation answers, this is what I'm going to get. So 0.89 and negative 0.56. I should put that in set notation. Okay, so those are my two answers. How should I write that? Pause and I'll show you the right way. Okay, finally got it. So it'd be 0.89 and negative point, well, that's a weird place to put a negative. Negative, oh gosh, negative 0.56. Okay, those would be my two answers. Okay, let's do another one. So let's do another one. Let's go through, find the discriminant. So here's A, B, and C. You know what? I'm going to write those down because it gets funky on this one. A is negative 2, B is negative 1, and C is negative 1. Yes? So I'm using my discriminant, b squared minus 4ac. So b squared negative 1 squared minus 4 times a times c. So I get 1 minus negative 8 times, oh, that's a positive 8. Because 4 times 2 is 8 times 1 is 8. But look, I have 3 negatives. So it comes out to be a minus 8. You see that? So I leave this minus. These two turn into positives, negative times a negative. So it's just 1 minus 8. So that gives me negative 7. Whoa, I get a negative under a radical. How many solutions do I have? Well, technically I still have 2, but they're not real. Okay, so what we're doing for now, so I would actually have 2. They would both be imaginary. So for now they're saying we're supposed to write not real solutions. Okay? You would have 2, they would both be imaginary. Okay, and I'm telling you that, so when you get into Algebra 2, you don't say, oh no, you can't get in it. Yes, you can. They just both happen to be imaginary. And by that time, you would have already learned about imaginary numbers. Now, because we don't know how to do imaginary numbers, this is not applicable. So NA, we can't do that. We cannot do it right now. It's not an empty set. It's just that we can't do it right now because we don't know about imaginary numbers. Okay, let's look at number 3. Now look at number 3 compared to 1 and 2. What do you notice? See how these are equal to 0? This one is not. This one is equal to 5. So the first thing we have to do is we have to get this equal to 0. So I'm going to subtract 5 from both sides. And I get 9m squared plus 6m plus 1 is equal to 0. And it makes a huge difference. Just like we never want to find quadratic formula unless we have 0 on one side, we don't want to find the discriminant. So let's go ahead and find the discriminant here. So again, we're going to take, A is 9, B is 6, and C is 1. So B squared, 6 squared, minus 4 times A times C. 6 squared is 36. 4 times 9 is 36. And times 1, of course, doesn't change the value. 36 minus 36 is 0. So remember what that means. If my discriminant is 0, think about quadratic formula. That means this is all gone. All you get is a negative b over 2a. So that means how many solutions? Exactly 1. There's going to be 1 solution. Okay, and to do this 1 solution, we might be able to fight it and fit it in there, but it's going to be pretty tight. So I'm going to take another piece of paper. Remember quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, so we have negative b, so negative 6 plus or minus, and this is 0 all over 2 times a. In other words, this doesn't matter. We get negative 6 over 18 in lowest terms. That would be negative 1/3. That's our only solution. Okay, that's all we do. Okay, so looking at the homework, this is all your homework. You want to get 0 on one side, everything else on the other. Then you want to use your discriminant to determine how many solutions. If my discriminant is 0, I have 1 real solution. If it's positive, if it's greater than 0, it's going to be 2 real solutions. If it's negative, it's no real solution, 2 imaginary solutions. That's what I should have said. 2 imaginary. Now, we can't solve it yet, so you know what? Let's just put that. From now on, we're going to put 2 imaginary solutions. We can't solve it, but we know they're going to be imaginary, and you can say, I'll accept either one. Okay? So you're doing this for homework. That's what you're doing. Great. If you have any questions, you know where to find us. Thank you so much.